Hi everyone, just wanted to take a moment to talk about graphing using function notation. So that way you can get an understanding and idea of what functions look like visually when represented in a graph. So we specifically as well are going to be looking at linear functions for the purposes of this, but ultimately this would apply to any type of function. So as you can see up here, I have my function notation to define my function. So I have f of x is equal to 3x plus 1. So every time I put in a different value of the domain, the x value, I'm going to multiply it by 3, add 1 to it, and then that will be my range value. Okay? So essentially, let's think about what would happen, right? So if I were to say I wanted to plot f of 3, okay? If I wanted the piece of information f of 3, I'm going to do 3 times 3 plus 1. So that would be 3 times 3 is 9 plus 1, right? And that is equal to 10. Okay. So what would happen if I plugged in my value of 3 plus the point 10? Okay. So see how it immediately plotted it? So all that we're doing right here is what we're doing is we're saying, okay, I have my f of 3. So I'm plotting the point 3 f of 3, which in this case was 10. So I have 3, 10. Okay, that's why I'm plotting this point 10. Now, I could do similarly with pretty much any other value, right? If I did f of 0, it'd be 3 times 0 plus 1, which is equal to 0 plus 1, which is just equal to 1. So my 0 comma f of 0 is equal to 0, 0, 1. So it should come up once we plug it in, right? Once I plug in 0, I get 1. And now let me clear my screen. So let's look at a few more, plot a few more points. So all we're doing is we're just plotting some points, 2, 7, 1, let's put in a negative, -2, -5. So you can't really see that, right? I have to zoom out. But what do you see it's making? It's making a line here, right? So if I were to draw this as a line, bam, as you can tell, it follows along. Now, however, that only is working because you know up here, right? If you looked at this, you would know that's a linear function. Um, so if you didn't necessarily have a linear function, it'd be a lot harder to tell. But ultimately, this is a great way for you to be able to find specific points, right? Because now what can I do? I can look at my little graph here and see if I can see any other points that might be beneficial. Okay, so let's do that with another one. So I'm going to change this. So again, I'm just going to change this to a new value. Oh, -1/2. Oh, and as you can tell, look at that. If I just leave it as -1/2, it should be a horizontal line, right? Because now we're essentially saying y is equal to just a constant. But x plus 3, right? So again, if I remove the line point and we just turn that part off, right? As you can see, if I were to turn this graph on, you can see they all go right through it. So these are the same thing. So this is just our way of getting the values and plots up for our particular functions. And it gives you a nice visual representation. Now, obviously, because this graph is based off of this function, I can't just throw something in there to make it change. But if it wasn't necessarily um, a graph like that, you wouldn't necessarily be able to get all of the points connected into a nice line like that, right? So if I had had something that all of a sudden in my table that wasn't related on this, if I had a value over here and the rest of these were in a line, right? But Desmos is not going to graph it as a total line, it's just going to do something like this, right? So just as a heads up on that, it's only connecting them and going on forever because it is going to be a linear function. But ultimately, that's just a quick overview on what is happening with your graphs. And again, as a quick reminder, just make sure we're all aware of it. We're plugging in an x value. We're plotting what comes out when you plug it into f of x. All right. So I hope that helps and that you can understand how to graph the functions. Let me know if you have any questions. Have a good day.